Meanwhile, back at the shack. Ready for one go.
Good antenna afternoon, everybody. KBOIP in East Tennessee. This afternoon, playing with the mega high dollar Tektronix scope and the I'm not so happy with it RF generator, which is set on pulse generation, but it ain't giving me a square pulse. It's giving me something badly attenuated in frequency. So my guess is the generator's overloaded or it's just junk. But anyway, 15 meter antenna testing, 21.1 megahertz is where the watt meter says it's optimal. There's the line to it. Essentially no reflected power, not even tenths of a watt, so that's optimal. What I want to show you is the effects of getting the length of the antenna wires, dipole, getting the wire lengths incorrect for the frequency. Now, it's obvious that frequency is related to wire length, wavelength, and all that. The watt meter can't show that when the wire lengths are incorrect, then the half cycles of the wave don't line up. They don't match. I showed you in earlier videos that propagation time out and back those wires is what the matching really kind of sort of is, in addition to the feed point matching. So there's all kinds of sources that can cause reflected power, but the watt meter cannot distinguish them. And that's why we go to TDR tests. The problem with TDRs, at least this one, is that it's a fixed pulse width. So that implies that I can't just pick any frequency antenna to work with. So I'm going to cheat by using the generator to change the frequency. That kind of, sort of, in a left-handed way, does the same thing. So here's a wave shape. When I change the frequency, 20.9, 21.0, 21.1 is optimum. You'll see the peaks of the wave, how thick they are, and now it's all the same. There are several sine waves lining up there. There may be 5 different sine waves implied here. And at 25 megahertz, they all line up at the same time. But notice on the top, as I go down through 23, 22 megahertz, 21, they're all pretty much lining up. Now with the antenna connected in place of the dummy load, little mini circuits RF load, and 21.1 Mickey cycles, run the frequency down. Watch that shape. That shape is a bit tilted. It's a bit lower on one side and the other. It's trying to make a square wave and it can't. But watch what happens. See how you can see a hump shifting? Big time. There's a hump over here that's changing. If you watch kind of closely, you can see them separate. Now they're kind of both the same amplitude. One's to the right, one's to the left. That's 20.8 megahertz, 20.9, 21.0, 21.1, 21.2, 21.3. This antenna is pretty flat up to 21.45, real flat. So a match is kind of indicated by all those wave shapes lining up. When the time is really turned off, 23 megahertz, you see these waves cycling through here, left to right, and doing all kinds of weird stuff. See, there's a big change right there. There's a wave there and a wave there and a wave everywhere. So this is kind of a crude TDR test. It's the best I can do with this cheap Chinese generator, apparently. It probably needs an amplifier. It's probably just overloaded. But there's all kinds of opportunities for mismatch here. This is just kludged together just for a quick test to see if I can see anything happening. And sure enough, there's a noticeable difference between the resistor load and the antenna. So let's use this high-powered scope and zoom way in and see what's happening down here at the bottom. Sweep, increase amplitude, yada yada yada, all kinds of knobs. The more knobs to turn, the more funner it is. Okay, more brightness. 21.1 megahertz, 20. See all the different shapes? There's a bunch of waves in there. Are they reflections or are they trash coming from the generator? I don't know. A spectrum analyzer would probably show up an unusually wide trace. But you see the hump shifting. There's a shape here. And then see that bright line, there's one over here. That's the weird stuff that happens when there's mismatch. So, not good. There could be harmonics in here. I don't know what all this junk is. But up through 21.4321, it kind of sort of behaves. Let's bring the sweep down just a little bit. Let's start turning the frequency up, and it goes. See, it's starting to lose amplitude. That's because it's badly mismatched. The generator's seeing more mismatch. And when a generator is more heavily loaded, the output voltage drops because the output of the generator is set at fixed 25 ohms. So when this sign display says about the same thing as the amplitude of a generator, which is about 3 volts peak to peak, at half a volt peak to peak at 1 volt, 1, 2, 3, well, that kind of implies that antenna might be pretty well matched. You see the amplitude holds pretty steady down 21.1. It starts dropping off. This antenna drops off fairly quickly at lower frequencies. Now there at 20.3 it picks back up again. But this is indicating what appears to be a resistive mismatch. But from about 21.0 to 21.5689, which where we can't transmit. I'm just using test equipment at low power. But that indicates more or less a resistive match, and that shows pretty broadband antenna. So something to mess with. KBYP.